absolute value equations. The goal today is to be able to solve an absolute value equation. Just a little background reminding you what absolute value is. We know that absolute value is a number's distance from 0 on the number line, so it's how far or how many units away from 0 a number is. And here you see two statements, the absolute value of -3 and the absolute value of +3. They're both equal to 3, and that's because both of these numbers are exactly 3 units away from 0. Absolute value is talking about distance, and whenever you measure distance, it is always positive. So just a quick warm-up. Here, this first one is asking us with these vertical bars, it's asking us what's the absolute value of -7. So how far away from 0 on the number line is the -7? How many units away? And we would say that that's equal to 7 units away from 0. Oops. So I would just put x, well, if my pen worked, I would just put x is equal to 7. Here it's saying what's the absolute value of +4.5? It equals what? And we know that that +4.5 is exactly 4.5 units away from 0. This one is asking us a different question. It's saying the absolute value of what number is equal to 6. So what number has a distance that's equal to 6 units away from 0? Well, there's actually two numbers, because both +6 and -6 have a distance that is equal to 6 units away from 0. So there's one way that I can write this here to include a positive and a -6. I can write plus and minus 6. And that's a notation that tells us it's the +6 and it's the -6. This one's asking the same thing. What number has a distance equal to 10 units away from 0? Again, there's two different answers. A +10 and a -10 both have a distance that's 10 units away from 0. So I would write positive and -10 using that notation. Okay. So moving along here, we're just going to look at two different absolute value equations. And right here, this is similar to what we just did. It's saying find the values of x that make the equation true. And being that we know that the absolute value, oh, I don't know what happened to my 5 here. The absolute value of 5 is equal to 5 units away from 0. But it's also true that the absolute value of -5 is also equal to 5 units away from 0. So being that x could be a 5 or a -5, I would state that x is equal to positive and -5. There are going to be two solutions, and that is because absolute value is a distance from 0, and you have two numbers that have a distance from 0, one on the positive side of the number line and one on the negative side of the number line. Okay, then over here, this one is stating find the value of x, but it's saying what number has a distance equal to -3 units away from 0. And remember, absolute value being distance, distance is only positive. If you think of all the things that measure distance, like rulers and tape measures, they all have positive numbers on them. So really, you can't ever have a number that has a distance equal to something that's negative. So we're just going to put a line through that negative sign, just like this, that says not equal to a negative number. Oh, get that out of the way. And so I'm going to write there is no solution to that. There's no solution for x because absolute value cannot be negative. Absolute value can only be positive because it's distance. Okay, so that leads us to our very first example, which is an absolute value equation. We got absolute value bars, we have an equal sign, so we're trying to solve for x. Now, if we were in class together, I would have us think about what couple values of x would make this true. And if you take a moment and think about it, you could probably come up with two different numbers that have a value for x that would make this true. But there's always a way that we can solve this algebraically. This is saying the quantity x minus 6 has a distance equal to 8 units away from 0. So I want you to think about this quantity right here. This x minus 6. Whoa, that was a big circle. That quantity x minus 6, I'm going to try that again. I kind of have some lag here, so it's really funny actually. trying to make us, oh my gosh, I don't even know what that was. Oh, this is going to be really comical. Okay. X minus 6, right here. Okay. This x minus 6, this quantity, is talking about numbers that have a distance equal to 8 units away from 0. Now, being that we know that 8 has a distance 8 units away from 0, but so does the number negative 8. It also equals 8 units away from 0. Both the 8 and the negative 8 could be representing this distance that's inside the absolute value bars. So what I'm going to do is pull that x minus 6 out of the absolute value bars twice. I'm going to pull out x minus 6 once, and then I'm going to do it again right here. Now this x minus 6 right here could represent an 8, or it could represent a negative 8, because both of those numbers would make the statement true. So I'm going to say that the x minus 8 could equal a positive 8, but it could also equal a negative 8 to make that true. So what I did was set up two equations, and now what I can do is solve for the two solutions for x. So this one right here would be x is 14, and then over here we'd have x is equal to negative 2. And if you were to put both of those numbers back right up here into the equation, if I put a 14 right here, 14 minus 6 would give us a positive 8 for inside the absolute value bars. And if I put the negative 2 up here for x, negative 2 minus 6 would give us the number negative 8, which we also said was a solution for that quantity. So here I can come up algebraically with those two solutions very easily. So what I did was I circled that quantity in the absolute value bars, I pulled it out twice, and I set up two equations to solve for x. Okay, let's try another one. Switch the color here. All right, whoop. All right, let's try this one. So this one you'll see that that absolute value is being divided by 9. That happens often in these equations, so you're going to want to first isolate the distance and get it all by itself. So I'm going to begin by just quickly getting the absolute value by itself. So being that it's divided by 9, I'm going to undo that by multiplying by 9, both sides. And then I have the absolute value of x minus 5 is now equal to 36. Okay, so I've isolated that distance, and now I know that that distance is actually equal to 36. Okay, now that I have the absolute value isolated, I'm going to look at the quantity inside right here, this x minus 5. Now if I was in the classroom, I would cover this up with my hand and I would ask you guys, what numbers could this x minus 5 be representing? Well, you guys would probably say that the 36, it could be representing a 36. The x minus 5 could be a 36 because that has a distance from 0 equal to 36 units away. But you also would probably tell me that that quantity x minus 5 could be a negative 36 because that number also would make the statement true. That number also has an absolute value of 36. So we're going to take the x minus 5 out. And see, I'm drawing two lines here. I'm going to take it out. I'm going to pull it out twice. X minus 5 could represent the number positive 36. Oop. Trying to get this to stay put here. Oh my gosh, it just wants to be all over the board. Okay, so x minus 5, could be positive 36. Then I pull it out again. X minus 5 could be equal to a negative 36. Those are the two numbers that would make this true. So now what I've done is created two equations that I can actually solve for the two solutions for x, because that's the goal, is to figure out what are the solutions for x. So if I add 5 to both sides here, we would have x is equal to 41 as one of our solutions. And then if I add 5 to both sides here, I would have x is equal to negative 31 as the other solution. So those are the two numbers that if I were to actually go back up here and plug in for x, they would make the equation true. We get two solutions again for this one. So our first step here was to isolate the absolute value, get it all by itself. That's always going to be your first step if it's not already by itself. So here's our next one. Here's number 3. And you'll see here how it says 17 plus 6 times a number. The absolute value of 6 times a number is equal to 5. Well, you could sit here and you could guess and check, and guessing and checking works. The only problem is sometimes it's not a whole number. So let's algebraically solve it. Let's first get the distance by itself. So we're going to isolate this just like an equation. We see here that the absolute value is being added to 17, so we're going to take away 17. That makes 0, take away 17 right over here. And now I get the absolute value of 6 times x is equal to negative 12. All right, so ready to solve this one. We'll go back to red. Now, this says, what numbers could 6x be representing? What numbers have a distance that is equal to negative 12 units away from 0? Uh-oh. Negative 12? There's no number that ever has a distance equal to negative units away from 0. So this, I'm going to put a slash to that equal sign. No way. This automatically right here, I'm not going to go any further because it's telling me distance is equal to a negative number. So I'm going to say right now we have no solution. There is absolutely no number that would ever get plugged in here for x that could ever make this equation true. No number that if I multiplied it by 6, took the distance of it, and added it to 17 is going to give me 5. Well, think about it. The absolute value is always positive. So no matter what goes inside this absolute value bar, it's going to be a positive number. And if you add it to 17, it can't ever equal 5. So we're going to say no solution. And that's what a no solution would actually look like. Okay, on to number 4. All right, let's see what happens with this one. I'm going to first start off with getting the absolute value by itself. So I want you to try to do that with me. So drawing a line down here. Now it says right here, negative 7, and it's stuck to the absolute value bar. So I want you to think about what invisible operation is happening in here. You guessed it, it's multiplication because it's stuck to it, invisible multiply. So if I want to isolate the absolute value and get it all by itself, I have to then divide by negative 7. And negative 7 divided by negative 7 will give you positive 1, and 1 times the absolute value is just the absolute value. Okay, but over here, if I divide this side by negative 7, oh, good. Negative divided by a negative makes a positive. So this is not going to be a no solution. Thank goodness. Okay, I've isolated the absolute value, so I'm going to think about this quantity right inside of here, 6 minus 2x. What numbers have an absolute value equal to 4 units away from 0? You would probably tell me 4 or negative 4. Both of these numbers here, 4 and negative 4, could represent the quantity inside of here to make this true. So you're right, you guessed it. We're going to pull it out twice. 6 minus 2x could equal 4, but the 6 minus 2x could also represent a negative 4. Either of those numbers would make this true. So let's now solve the two equations for the value of x. You do it on your paper, I'll do it on mine. All right, are you getting the solution x equals 1, and then also the other solution is x equals 5? Me too. And in this case, both of the solutions happen to be positive numbers. We haven't seen that yet. So both of those numbers, if I plug them into here, up here for x, they would both make this entire equation true. So here we see two solutions again. Okay, this process is kind of repeating itself every single time. We're doing the exact same thing. Okay, let's see what happens in number 5. You know what to do first. Get the absolute value by itself. Isolate it. In this case, it looks like it's going to take 2 steps. What would be the first step? See the X is up here on the top, like this is like the top floor, and we got the weirdos in the basement. You're right, let's get rid of them. Let's multiply by 8. Yeah, you're probably noticing there's a negative on this side, but over here on the left, this is -5 stuck to the absolute value, so that means that there's an invisible multiplication happening here. So the inverse of that would be to divide. And when you divide by -5, you see here how we're going to end up with a positive distance. +8. Woo, finally. Okay, good news. Oh, that looks like a fun color. Okay, so remember the goal is to come up with the solutions for this x way up at the top of the equation. We've isolated the distance. Now I think we're ready to set up 2 equations. So think about this distance right here. What 2 numbers could it represent? If I covered it up with my hand, what 2 different numbers could go in here to make it true? And you probably would say 8 or -8. Both of those would make it true because both of them have a distance equal to 8 units away from 0. So pull it out twice. Don't skip this step. Actually show your work. 3x minus 2. And then set it equal to 8. And then over here we want 3x minus 2 again. And now here we're going to say the other solution that could be would be -8. So you have 2 equations to solve. And these will give you your 2 solutions. Now in this case, this is the first one here where we end up with a solution that is not an integer. So we have 10/3, which is the same thing as 3 1/3 or 3.3 repeating. Any of those would work. And of course, you can probably guess that would be very hard to sit and guess and check because that's not an integer. So there's one of our solutions. Now let's go over here to our other solution. Okay, it looks like this one we're going to get an integer for. Are you coming up here with -2? Me too. Okay, so we got 2 solutions. One happened to be a fraction or a decimal. The other one is x equals -2. And those would be the 2 solutions you could plug up here for x. So not always are you going to get something that works out really nicely. That's easy. Okay. Whoop. Gone too far. All right, number 6. Can you do it? You can always pause the video too and give it a try and see how you do. It's up to you. We'd have to first isolate the distance. I mean, guessing and checking, you could try it, but that's kind of a lot. So what would you do first? You see the -10 is stuck to this x plus 5, kind of like closest friends. You guessed it, we're going to send home the acquaintances. We're undoing the add and subtract here. Ooh, I have to squeeze it in here. Equals 77 plus 3 would give us 80. Okay, another one like this where the -10 is stuck with multiplication, so that means we got to use division. That will change it into a 1, x plus 5. And then I got to divide this side by -10 also, giving us a -8. All right, let's see what kind of color I got on the color wheel this time. Okay, so we've isolated the distance, and here it says the distance of this expression right here is equal to -8 units away from 0. Whoa, do you notice it? The negative, you cannot have a distance. These absolute value bars are saying distance. It says distance is equal to negative. You can't have that. So right here, no solution. What happened to my S? No solution. There is no solution for x. There's never going to be a number that you could plug in here that would ever make this true, because the distance is being represented by a negative number here. When you isolate it, you can't have that. So never going to work. Okay, so we saw 2 of those, so hopefully now on your own you could recognize that if you saw it again. Finally, we have made it to the last example. All right. Oh, not summary yet. Okay, so last example. Something different's going to happen here. Get excited for that. Okay, let's isolate it. Here's the absolute value. It's being added to 6. You know what to do. Oh. There we go. Equals 6 minus 6 is 0. Okay, so we have the absolute value of this quantity is equal to 0 units away from 0. That's funny. Okay, so let's circle it. What numbers have a distance? What numbers could this quantity be representing? What numbers have a distance that's equal to 0 units away from 0? What has a distance that's equal to 0 units away from 0? What would you say could go in here? Yeah, only one thing, 0. The only number that's 0 units away from 0 is 0. So instead of pulling this out twice, we're going to pull it out one time, and we're going to say that the only thing that this quantity could represent would be the number 0. So you guessed it, we are only going to get one solution for this because we isolated it and it said distance is equal to 0. So we got to actually solve for x. The answer is not 0 necessarily. We have to actually solve for the value of x. So that's what I'm doing now. 0 plus 4 is 4. Divide, and I get x is equal to 4 divided by 8, or 4/8, which we know simplifies to 1/2. And I'd take 1/2, 0.5, 0.5, whatever. So that means if I go up here and I were to plug in the number 1/2, it would make this true. And we know 8 times 1/2 is 4, and 4 take away 4 makes this whole quantity a 0, and 0 plus 6 equals 6. Check. It worked. So in this case, you only get one solution. All right, so now I think we've done enough examples. You guys have seen everything. Let's go to the summary. Okay, so first thing in the summary we've got here is steps to solve an absolute value equation. So you first want to check to see if you can get the absolute value by itself. Okay, that means isolate it. So if it's being added to something, subtracted, multiplied, divided, you have to undo that to get it by itself. Now, in number 2 here, if you get the absolute value by itself and it says that it's equal to something that's negative, what does that tell you? Yep, it tells you there's no solution. You get to stop, and answer is going to be no solution. Now, what happens if you isolate the absolute value and it says it's equal to 0? There's only going to be one solution. Yep, just pull it out one time and you got one solution. But if you get the absolute value by itself and it says it's equal to anything that's a positive number, like 6, for example, that tells you you're going to have 2 solutions. So you got to circle it, pull it out twice. So in most cases, you're going to get 2 solutions. So for step 3, we're going to say, in most cases, you will be setting up 2 equations to solve for the solutions, because these 2 actually are pretty special cases. All right, and that takes care of it. That is our lesson on solving absolute value equations. Thanks for joining me.